Hey everyone, so welcome to this video, and in this video we are going to discuss one more problem on binary tree, right? So the problem is very interesting and I'm pretty sure you will love this question, okay? So the problem statement is you'll be given two nodes, let's say node number n1 and node number n2, okay? And you need to find out whether these two nodes are cousin nodes or not. Cousin nodes. So let's say if n1 and n2 are cousin nodes, then in that case you need to return true, or if these two nodes are not the cousin nodes, then you need to return false. Okay, so instead of returning true, you can return or you can print yes, right? And in this case you can print no, correct? So this is the actual problem statement. So before discussing the problem, let's discuss what exactly cousin nodes means. So you're familiar with cousins, okay? So in this tree, let's talk about node number 4 and node number 8. So here you can see that the parent of these nodes are same. 6 is the parent of these two nodes, and level of these two nodes are also same. Okay. So this is level number 0, this is level number 1, and this is level number 2. Okay. So these two nodes are not the cousin node because the parent of these nodes are same. But if I talk about node number 4 and node number 15, so here in that case, the parents of these two nodes are different, but the level of these two nodes are same. This is level number 2. Okay. So here level is equivalent to the generation. Okay. Generation. So the generation of these two nodes are same. Okay. But parents of these two nodes are different. So that's why these two nodes are considered as cousin nodes. Similar case is of 8 and 21, also 8 and 15. Okay, so and here also 6 and 18 are not the cousin nodes. Okay, because parent is same. So this is the basic idea about cousin nodes. Now let's try to understand how to check that whether these two nodes are cousin nodes or not. So here we need to take care of these two conditions. Condition number 1, we need to have a record of levels of each of these nodes. Okay, so we need to check the levels of both the nodes. Okay, levels. And the second thing is we need to check the parents of those nodes. Parents. So if the level of those two nodes, that is n1 and n2, are same, if level is same but parents are different, then in that case those two nodes will be cousin nodes. Okay, so for nodes to be cousin nodes, level should be same but parents should be different. Okay, so this is the condition. Now let's try to build this logic. Okay, so what I'll do, I'll create a BFS function and I'll store the parents of all these nodes, that is 10, 6, 18, 4, 8, 15 and 21, as well as the levels of all these nodes. Okay, so for storing the levels, that is, let's say if I want to store the level of 6, okay, if I want to find out the level of 6, so what I can do, I can write it as like level of 6 is equal to level of 10 plus 1. Okay, so in general form, if I talk about the level, so we can write it as like level of child. Okay, level of child is equal to level of parent plus 1, because this is level 0, this is 1, this is 2. So let's say if I talk about level of 15, so it should be equal to level of 18 plus 1. Okay, so this is the idea how you can find the level of all of these nodes. Now let's try to build this logic. So this is the basic program for this tree. Okay, the node values are also similar. So what I'll do here, I'll create a BFS function. So void BFS, and here I'll pass the root node. Correct. Now the first thing that I'll do here is I'll create a queue. Okay, queue of node, and I'll push the root node inside that queue. Now we need to create a while loop here, and the condition is queue is not empty. Okay, and after that we need to fetch the front element of that queue. So I'll create a temporary variable here, and queue dot front as the method, and then we'll pop out that element queue dot. So this is the idea. Now we need to check on the availability of left and right child. Okay, so let's say if left child is available, if temp of left is not null, then what we'll do, we'll store the parent as well as the level of this node. Okay, so for that I need to create a parent array. Okay, so let me create that here, int of parent max, and I'll initialize it with 0, and similarly int of level, that is max, and that is 0. Okay, and let me define max here. That is 100. Okay, so array. Okay, yeah. Now what we need to do, we need to store the level as well as the parent of each of these nodes. So first let's store the level. So level of temp of left of data, because this is an array integer. Okay, so level of temp of left of data is equal to level of temp of data, that is the parent node, plus 1. Okay, and for parent array, parent of temp of left of data, that should be is equal to temp of data. Okay, so what we are doing here is we are storing 10 inside parent of 6, means parent of 6 is equal to 10, and level of 6 is equal to level of 10 plus 1. Okay, so this is the idea, and after that we need to push this element inside the queue. So I'll write queue dot push and temp of left. Okay, now similar thing we need to do it for right child. If temp of right is not null, so in that case we'll do this thing, temp of right of data. That's fine, temp of right of data is temp of data. Okay, and here we need to push the right child. Okay, so that's completed. Now we need to call this function in main, and here I'll pass root node as a parameter. So to check whether the two nodes, that is n1 and n2, are cousin nodes or not, so for that the condition is if parent of n1 is not is equal to parent of n2, and level of n1 is equal to level of n2. Okay, so this is the condition, then in that case we'll simply print cousin nodes. Okay, and if this condition is false, then we'll print not the cousin nodes. So yeah, and this is the idea. Now now let me define these n1 and n2. Okay, so let's take n1 as, or let's take n1 and 2 as an input variable. Okay, now let me compile this first. So it is compiled successfully. Now if I run this, okay, now let's see this tree. So let's check the, one second. Okay, so let's take the value of n1 as 6 and the value of n2 as 18. So in this case it is not the cousin nodes. Okay, so it is correct. Now if I take n1 as 4 and n2 as 15, so in this case it is actually the cousin nodes. Okay, 4 and 15 are cousin nodes. So here the output is true. And let's check for 8 and 15. So here also the output is true. Now let's check for 15 and 21. Okay, here we have 21. So for 15 and 21 it should be false. So it is false. So this is how you can code this algorithm. Okay, and you can find out whether the two nodes, that is n1 and n2, are cousin nodes or not. So that's it for this video. Thank you.